first, I'm sorry if there's a lot of background whirring machine noises. My bad. But for this problem, we are solving for the closed form solution of a recurrence relation. So recurrence relation looks like this, some equation that looks backwards at previous terms. Closed form is the version of the equation that doesn't look backwards. We've done this type of problem before, back in like midterm 1 material, but there we had a specific way of dealing with it where we like wrote out other terms, plugged in a 0, looked at it, found the pattern kind of thing. And it's okay if you don't remember that because we're not doing it here. Here we are very nicely plug and chug. A specific way you do these problems, just do it. I actually have no idea why it works. Something related to differential equations in Calc 4. I haven't taken that. I don't know anything about it. Don't ask me any questions, which you can't. Convenient for me. So just do it, and I will show you how. Okay, so step 1, we take this recurrence relation, and anywhere we have an a sub n, we change to an x to the n. So we get x to the n equals 6 times x to the n minus 1 minus 9 times x to the n minus 2. Then we go and we simplify this thing. And in this case, we divide each term by x to the n minus 2, which is really nice because we get x squared equals 6x minus 9. Put all the terms on one side. Don't mess up your minus signs when you do that. Solve this quadratic. I know you might not have done this for a while. And find the roots of the quadratic equation you're left with. And so in this one, the roots are x equals 3 and x equals 3. So this is a root with multiplicity 2. You don't really need to know that word. But if we had solved this equation and we had 2 different numbers as the roots, we would come, look at this fancy equation, and plug in the roots for R1 and R2. The issue here is that we really only have one root, the number 3. So what we're going to do with the second term is multiply it by n. So now we're still going to use this equation, but the second term is multiplied by n, only in the case where a root is more than once. Okay, so what we do with this weird looking equation in step 3 is we plug in the roots, and now our answer is going to take on this form. Like this right here will be our answer, but we're going to solve for C1 and C2, which are constants. So they're just going to be numbers, and we need to find them, and then we'll have our final answer. So almost there. The way we find them is we take the initial conditions that were given to us, and we make equations from them. So like A0, it equals 1, because they told us in the problem. And from step 3, we know it equals C1 times 3 to the n, which n is 0, so I should plug that in. C1 times 3 to the 0, plus C2 times 3 to the 0 times 0, so we don't care about that term. 3 to the 0 equals 1, so we're left with C1 equals 1. This is really convenient, but sometimes in these problems we end up having to solve a system of equations. If you're not very familiar with that, that was like the substitution elimination things. If those don't ring any bells, Google system of equations. Khan Academy will certainly help you out. Okay, to finish this off, we need C2. So we use the other initial condition, A1 equals 6, which equals C1 times 3 to the 1 plus C2 times 3 to the 1 times 1. Plugging in what we know, we get 6 equals 1 times 3 plus C2 times 3. Solving for C2, we get that C2 also equals 1 in this case. So now the only last thing to do is take this equation and put C1 and C2 in there. So our final answer is A sub n equals 1 times 3 to the n plus 1 times 3 to the n times n. Oh shoot, I ran out of space. That looks terrible. I'm just going to write the n over here. Like that. And that's it. We did it. I don't know why we did it, but we did. And that's the answer. And so that's all that I have. Oh wow, my arm disappears. If I put it right here. Oh my gosh, look at that. Wow. Okay, I'm done. I should delete this part out of the video, but I probably won't. I hope you enjoyed that as much as I did. Okay, I'm actually done. I'm stopping this video like a responsible person now.